we continue with the series of 2023 number challenges. Do check out previous videos. I have some innovative problems regarding number 2023. Today, we have the set of integers from 1 to 2023. Sometimes we have this notation here representing this set. Now we define a value x for all the subset of A. Okay, so if the elements are A1 through AK, then we define x of this subset -1 raised to this power, the sum. Okay, so here if the set is empty, we assume the sum is 0, so the value is 1. Now the question here is to find all subset, what is the summation of x, right? So each value either be 1 or -1 depending on the odd or even of the sum of the elements in the subset. Okay, so it may be complicated, but make sure you understand the meaning of it, what we're looking for. Pause the video, try to solve the problem. Okay, so first of all, we should realize the brute force. That is, you try to enumerate all the subset. That simply won't work. For a given set A and the set of all subsets, sometimes we call it power set of A, has the elements 2 to the 2023's power. It's a huge number, right? This power set is all subset, is a set of set, okay, including the empty set and the set A itself, okay? So that means we simply cannot do the brute force in this case. Now when we do some analysis, earlier we know that what matters for the value x is the parity, that is the sum being even or odd. We call it parity, right? So the parity of the sum of elements matters. Okay, so for this sort of problem, sometimes a common trick we use is to consider a particular subset and its complement or some other relation. All right, so let's try with that approach. Now, first of all, what is the sum of all the elements, right, of A? Okay, you add it up, that's an even number. You don't have to calculate out, you know that's an even number. So which means if you want to pair a set S and its complement, it won't help. Why? Because if the total sum is even, if a subset S has odd of the results, then the complement also has odd. That is, each contribute -1 and -1. The sum of element S is even, then so is the complement because the total sum is even number, right? So which means in that case you contribute to 1 and your complement contribute to 1. That's 2, right? Intuitively, you may think, all right, maybe there's some symmetry in this. That means somehow it cancels. We can pair them up. That the final answer is 0, right? But of course, the typical approach of using a set versus a complement of that does not work. Let's try a different direction. Now we're going to consider if the element 1 is in S or not. Okay, so in that case, you can divide the power set of A into 2 sets. That is, either the subset contains element 1 or it does not. All right, so here notice that P and Q are set of sets, and P and Q together is the power set of A, and they are mutually inclusive. All right, so you can establish one-to-one correspondence between element in P and Q. How do we do that? For all the element S, which is a subset in Q that does not contain 1, you can add 1 to it, and this will map the set S prime in P. So you establish one-to-one onto, right? That means P and Q are equal size, right? And notice that for element S and S prime, because they only differ element 1. The sum is going to have different parity, right? So if element in S add up to an even number, S prime, because you add 1 to it, become odd. So in that case, we know that we pair up S and S prime. With this approach, we argue that everything would cancel each other because one would produce -1, the other one produce 1. So they cancel each other. So that is the answer. All right. So when I explained this to one of my friends, she couldn't understand, but then I tried to explain a different angle. She finally got it. Here, what we consider is for the one that does not contain 1, for the Q, right? When you think about it, Q is nothing but a subset of this set. If the set B does not have 1, right? And then, all the subset would be identical to the Q as we defined. That is the original subset of A that does not contain element 1. Okay, so here, you know that the sum here is odd. Now we can use maybe an easier to understand argument that consider a set versus its complement, because the total sum is odd if the set S has even parity, that is, as we defined earlier, the element add up to an even number, then SC, the complement of it, would be odd because the total has to be odd, right? So, and that would cancel each other because one would be -1, the other one would be 1. All right. So that is for the elements in Q, right? The subset that does not contain 1, they would have the total sum be 0. Now for the set P of all subsets that contain element 1, we know that by adding 1, you change the parity. That is, those sets would have the total sum of -1 times this sum, but this sum is 0. -1 times 0 is 0. So for the elements in P, the total sum is also 0. So 0 plus 0 is the total answer. That's 0. Okay, that's a different angle of the same argument. Okay, basically element 1 is in the subset or not. That's the approach we use. All right, so hope you enjoyed the video. Please like, share, and subscribe to the channel for other 2023 number challenges.